So let's see how we can use the Pascal's triangle to help solve simplify expressions and expand these out. So x plus 1 to the power of 5 would be really long if we tried to expand it out manually. But using the idea of the Pascal's triangle, if you have a look, this is the expansion here, and then we're going along the pattern from before using these ideas. But if we have a look, like you see the 1, 5, 10, 10, 5, 1, the sixth line of Pascal's triangle. And that's the one that corresponds to the 5, so we start off with the 0. So the fifth one, the 5 there would be the sixth line. So you notice we get an x to the power of 5, power of 4, 3, 2, 1, and x to the power of 0. And it's because it's multiplied by 1 there, so the 1 is not going to make any difference. But you can see how the line of Pascal's triangle is going to come into play. Let's have a look at the next one here, like even more so with the a plus b to the power of 9. So you can see it's going to be long because there's 10 terms in there. If it's power of 9, it's going to be 10 terms. So there's always one more term in the expansion than there is for the power there. So again, you can see the 10th line of Pascal's triangle coming into play, those numbers there. And notice what happens with the a and the b, with each term here. A is going to start at 9, then 8, 7, 6, 5, 4, 3, down to a to the power of 1, and then 0. A to the power of 0, and b is going to go up by 1. So you can see how b's going up by 1 each time until we get to b to the power of 9. So, and that's this expansion. And notice the line of Pascal's triangle in there. So again, the 1 to the power of 6, x plus y to the power of 6. So you can see x power of 6, x power of 5, x power of 4, 3, 2, 1, and then y is going up by 1 each time. So you can see what happens and how the patterns come into play. And again, that 7th line of Pascal's triangle, the 1, 6, 15, 20, 15, 6, 1. So that symmetry happening as well. This one's a little bit different, a minus b to the power of 3. So again, what we've got to consider is the 1, 3, 3, 1 as Pascal's triangle. But this time, they're going to start with the a to the power of 3 and the minus b to the power of 0. So the negative is going to have an effect. So the first term is going to be positive. But then we've got 3a to the power of 2, because the power on a goes down by 1, but the power of minus b goes up by 1, so it becomes b to the power of minus 1, which is going to make it a negative. So that's why we get minus 3a squared b. And then minus b in the next term is squared, so it's going to be a positive again. So you can see how that evolves, and so every second term starts to be alternating between positive and negative. So, and then the 2 plus x to the power of 5. What we've got to consider here, the 2 there, again, we're going to have our terms from the Pascal's triangle, and that 6th line because of the power of 5. But this time we've got the 2 to the power of a 5. Then 2 to the power of 4, to the power of 3, to the power of 2, power of 1, power of 0. So, and then the x starts to go up by 1 every time, but we've got to consider the values of 2 to the power of 5 is 32, 2 to the power of 4 being 16, times the 5 gives us 80, 2 to the power of 3 is 8, times 10 is 80. So you can see that it does have an effect. So we're not just going to see our line, our Pascal's triangle line there, because they're going to be multiplying by some numbers when it's a number other than 1 there. So keep it in mind, we're seeing the pattern of what happens. Our first term goes down by the power in the powers, that's saying 5 down to 0, and the second term goes up in terms of its powers and being multiplied by itself. And we've also got the multiplication factor of the line of Pascal's triangle.